Okay, so in this video, welcome back. We are going to see the Demorgan theorems. In the Demorgan theorems, first we will define the Demorgan theorems. The two Demorgan theorems are there. The first Demorgan theorem, first we will define it for two variables. Okay, so here, first I will take this as complement of the product is equals to sum of the individual complements, like this. Second one, complement of the sum is equals to a product of individual complements, like this, right? So it's very simple. You can just go through this two formulas of De Morgan theorem. The first De Morgan theorem, complement of this product is equals to sum of the individual complements. Complement of the sum is equals to product of the individual complements. Okay. So also we can remember like this, just like this. Break this line, A dot B. Break this line, change the sign. Right? So this is how we can also remember. Same applies here. Break the line, change the sign. What is that? Break and change. So many students will get confused how exactly we should write it. Should break the line and change the sign. Now we should go for the proof. So how to go for the proof? So here, proof. Since we have taken two variables, so we'll write those variables A and B. Right? So after that, I am going to take this, the first one. With respect to A, what is the next is there? A complement is there, I will write it. With respect to B, what is there? B complement is there, I will write it. Then after that, I will write here the LHS. The LHS is complement of AB. So first I will write AB. Later I will write AB complement. And at the last, I should write this. So instead of writing that, you should add this and this, right? So it is this, right? So we should go for the proof. So how to go for the proof is, right? These are the variables we'll be having. So the general format is, how many number of variables are there? 2. So you should always go for this 2 power n. 2 into 2. What is 2 into 2? 4 possible combinations of 1s and 0s you will be having. What is the first possible combinations? 0, 0. What is the second possible combination? 0, 1. What is the third possible combination? 1, 0. Fourth possible combination is, it is 1, 1. So for these combinations, we should write the De Morgan theorem. That there is a verification of De Morgan theorem, and it is the first one. What is the first one? So it is this one. We are seeing, right? So now, how to write the A complement? Wherever 0 is there, complement means we should negate it. We should inverse it. So negate it. It is nothing but not gate. If it is A, it is A bar. If it is 0, it is 1. If it is 1, it is 0. So 0 is there, 1, 0 is there, 1, 1 is there, 0, 1 is there, 0. So for B, similarly, B negate 1, 0, 1, 0. Right? So now AB, what I should do? I should go for the product. 0 multiplied by 0, 0. 0 multiplied by 1, 0. 1 multiplied by 0, 0. 0 multiplied by anything is 0. 1 multiplied by 1 is 1. Right? So now I should go for the complement of this. So complement of 0 is 1, complement of 0 is 1, complement of 0 is 1, complement of 1 is 0. Next, go for the last one. A bar plus B bar. We can call it as also bar. So this plus this. What is 1 plus 1? 1. What is 1 plus 0? 1. What is 0 plus 1? 1. What is 0 plus 0? 0. Right? So this also we should know. 0 plus 0, 0 plus 1, 1 plus 0, 1 plus 1. 0 into 0, 0 into 1, 1 into 0, 1 into 1. 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 1. 0 into 0 is 0, 0 into 1 is 0, 0 into 1 is 0, 1 into 1 is 1. Right? So this is a addition and this is a multiplication. Sorry. So you can look at now LHS. What is LHS? Complement of AB. So complement of AB. So this is LHS. What is RHS? Sum of individual complements. That is this one. Now this LHS should be equal to RHS. Look at this. This is a column is exactly equal to this column. Right? Hence the first Demorgan theorem is proved. What is the first Demorgan theorem? Complement of AB is equals to complement of A plus complement of B. Right? So this is how we should derive the second one also. Right? So we can derive the second one. How for that we should take the variables. What is the variables? A and B. We have already taken. Right? So now we are going to modify this. Whether you want A bar is there, yes. Whether you want B bar, yes. Next, what is that? After that, you want E after A bar and B bar. What you should get here? You should get it as A bar into B bar. A bar into B bar. Right? So what are the variables are there? We are writing that. After that, what is there? A plus B is there. So I will write here A plus B. But what is there? Complement of A plus B. Right? Now, this LHS and RHS will be changing. What is that? What is the LHS? This is the LHS. And what is RHS? This is the RHS. And these entries, I will just erase because it is the first one. Right? So now, right? So this AB and this complement of A and B remains same, but here we should do the multiplication with respect to these two. What is 1 into 1? 1. What is 1 into 0? 0. 0 into 1 is 0. 0 into 0 is 0. Right? So what is A plus B? Add these two. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is 1. Right? What is complement of A plus B? Here it is. A plus B. Complement of this. Complement of 0, 1. Complement of 1, 0. Complement of 1, 0. Complement of 1, 0. Right? So now look at the LHS and RHS. What is LHS? What is RHS? Both are equal. Hence the Demorgan theorem is verified. Right? Demorgan theorem, we have done it for how many variables? 2 variables. Since it is 2 variables, how many possible combinations of 1s and 0s we got? 4 possible combinations of 1s and 0s got. 4 rows we got. Right? Suppose if I ask the question, can we draw or can we do it for 3 variables? Yes, correct. So how to do it? Just extend this. How to extend this? So now here this complement of AB becomes ABC, and here one more extra, that is C bar. Here it is complement of A plus B plus C, and it becomes one more extra. Right? How many number of variables now? 3. So 3. So what is 2 power 3? 8 possible combinations of zeros and ones we will get. Right? So if we want to write it in a very clear way, so that we will understand that in a better way, I will do it for only one, the first one. Second one I will leave up to you because it is very simple. So we will see for a Demorgan theorem for 3 variables. Right? So we will see for 3 variables how many rows we will get. 8 possible combinations of 1s and 0s means 8 rows we will get it. So we can do it for 8 rows. So here to write it clearly, so I will rub this and we will see for 3 variables because it is the most frequent question they will ask again and again in the basic electronics or wherever you can take our introduction to electronics. First one, complement of, you can write it as product is equals to sum of individual complements. First Demorgan theorem. Second one, complement of the sum is equals to product of individual complements. So this is what it is there, right? So now we'll take the help of these A, B, C. Three variables are there. So we know that three variables means 2 power 3. It is 8 possible combinations of ones and zeros. Simply 8 rows. So first is A, second is B, third is C, right? So we'll write the first possible combination. It is 000. Second possible combination 001. Third 012, 010, 3, 4, 5, 6, 7. So we got 7 possible combinations. Sorry, 8 possible combinations, right? So we'll see now one by one. So we have written A, B, C. After A, B, C, look at now. I want A bar, B bar, C bar also there, right? So I want A bar, B bar, and C bar. So this extension we should take, right? Then after that, what we should take? So I will go with respect to the first one now. After A bar, B bar, C bar, so what we should do? We should add it. So I will take A bar plus B bar plus C bar. And we should call this as what? This as RHS. Is it RHS? It is RHS. What is LHS? ABC complement or complement of ABC. Whether ABC product we have taken earlier? No. So what you should do? You should take ABC product first. Then after that, complement of ABC. Right? So out of this, which is LHS now? The LHS is this one. Right? So now for this, you should start doing the entries. Right? So first one, complement of A. Wherever 0 is there, start writing 1. So look at this. This is changed to this. Wherever B, complement of B means wherever 0 is there, start writing 1. Wherever 1 is there, start writing 0. So C, complement of this, 0 is there, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0. Right? Now, after that, addition of these three means this and this and this. What is 1 plus 1? 1. What is 1 plus 1? Still it is 1. Right? What is 1 plus 1? It is 1. What is 1 plus 0? It is 1. What is 1 plus 0? 1. What is 1 plus 1? It is 1. What is 1 plus 0? 1. 1 plus 0? 1. Right? So, like this, what is 0 plus 1? 1. 1 plus 1 is 1. 0 plus 1? 1. 1 plus 0? 1. 0 plus 0? 0. 0 plus 1? 1. Last one, 0, 0, 0 is 1. 0. Right? Then ABC, we should do the product of these three. So, if any 1, 0 is there, it is 0. If any 1, 0 is there, it is 0. So you will get 0 up to here because 1, 0 is there in each row. Only for the last one, there is no 0, so you will get 1. Right? So after that, we should do the complement of this. Wherever 0 is there, start writing 1. Wherever 1 is there, start writing 0. Now we should compare the LHS with the RHS. Right? Both are equal. Hence, verified. What is verified? 3 variables for the first Demorgan theorem is verified. So I will leave up to you with respect to the second one. State same in the similar fashion you start taking. Up to here it is same up to this one. Then after this you should start changing this. What you should start changing? So here A bar, B bar, C bar you should write. Right? So that is you should write like this. Then A plus B plus C whole bar you should write. Right? And A plus B plus C, you should write one more, right? So like this, I will leave you to second one, start with. Thank you. Stay tuned to this channel for the introduction to electronics or basic electronics, and we'll continue these whatever which is related to electronics in the coming classes. Thank you. We will see in the next video. If any doubts are there, put it in the comment section. Thank you.